I started with retaining wall. And I told you we have a side called active earth pressure, and we have another side called passive earth pressure. Active earth pressure equal K active gamma H. K active gamma H. K equal 1 minus sine phi divide 1 plus sine phi, where phi is the angle of internal friction. All of this stuff is related or are related to soil mechanics. I need only to highlight something here, and I will start with an example. If you have water table, sometimes we have a water, underground water. If you have a water, this water, if you go back to hydraulics, this water will cause a triangle pressure, and the pressure here equal gamma water time H. At the top or at the water table surface, we don't have H for water. So your value here is 0. At the end, we have H for water. If you multiply this H times gamma water, I can construct this triangle. I'm talking this pressure coming from water only. So we still need to draw the pressure due to the effect of soil, which is gamma soil H soil times K active. Guys, remember all the time, if you are talking about lateral pressure due to soil, it's not gamma H only, it's gamma H times K active or passive. If you are talking about water, lateral pressure equal gamma H. That's fine. We don't have K for water. We don't have K for water. Okay? Any question? And also, if you have soil without water, you can use this gamma. But if you have soil with water, the gamma here must be subtracted by 62.4 before using it. Can you tell me what is the meaning of 62.4? What is the meaning of this value? Do you remember? Do you remember the meaning of 62.4? Thank you. Gamma of water. Gamma of water. Why you subtracted gamma of water from gamma of soil? Because you already separated the pressure of water alone. So I will not use it 2 times. I draw the effect of water alone with a triangle. So when you are trying to calculate the soil pressure, please subtract gamma water from the gamma soil. Let's start to do example number 1. We have a retaining wall. This retaining wall supporting the soil on the right side. Here is the ground surface. So I believe this one will be active because this soil is trying to push this retaining wall to this side. Okay? We need to figure out the lateral pressure. Lateral pressure. Gamma of soil is given, I think. Dry unit weight density is given 100 pound per cubic feet. and we have another gamma equal 140 pound per cubic feet. What is the difference? Which one I'm gonna use? That's fine. It's a good question. Please read carefully. Dry unit weight. So this one will be dry without water. I believe you are talking about this part of soil without water table. And we have another part of soil inside water table. So this one will be gamma saturated equal 140. Groundwater table was found at 8 feet. No, it's not at 8 feet, at 12 feet from the ground surface. 12 feet. Compute the total active force per unit length of wall. We need to figure out the lateral pressure. Let's start. I will use this figure to construct the lateral pressure. Can you tell me phi for this soil equal 32? So I can figure out the value of K active, 1 minus sine phi, divide 1 plus sine phi. Use your calculator. 1 minus sine 32, divide 1 plus sine 32. This value equal 0.31. Let's start. Do you have water table? Yes. Please go ahead and draw the pressure due to water. At the top of the water surface, we don't have gamma H. We have gamma, but we don't have H. So gamma H, gamma water, H water equals 0. At this location, we have gamma water, H water. Gamma water 62.4. H water is 8. So this pressure will be 499.2 pound per square feet. This triangle only due to the effect of water. Let's start to draw the lateral earth pressure due to soil. At this point, what is the value? At this point, what is the value? Pressure for soil equal K active gamma H summation. Do you have any H for soil here? What is the H? What is the height of soil above this point? We don't have anything. So the pressure here will be 0 at point number 1, point number 2, point number 3. So P1 equal 0. We don't have H soil above this point. Pressure at point 2 equal K active 0.31. Gamma of soil, which is gamma dry, because you are here, gamma dry 100. H of soil above this point 12. Your value will be 372 pound per square feet. P3 equal previous value, which is B2, 372 plus K active gamma H for the new soil. K active 0.31. Gamma of soil. Do you remember what is the value of gamma of soil for soil under the water table surface? 140. Because you already separated the effect of water, so I need to subtract gamma of water. Be careful about this point. Be careful about this point. What is the height for the new soil above this point is 8. Guys, remember, because I said pressure at point 3 equal pressure at point 2 plus the new soil between point 3 and point 2. So this H between point 3 and point 2. This gamma between point 3 and point 2. Because we have water, so I subtracted 62.4. This value will be 564.4. Go ahead and put your numbers. 0. The value here is 372. The value here is 564.4. We have this shape. Any question? Looks good. But we don't, the problem didn't ask to calculate pressure. The problem asked to calculate the total force. Okay, we need to convert this pressure to force. I think this triangle can be converted to a force. How? Get the area of this triangle. Area of triangle 0.5 times base 499.2 times height, which is 8. This force will be 1996.8 as a force. We have a complicated shape here. So I will divide it to triangle. I can figure out the force. And this trapezoidal, if you would like to divide it to rectangle with a force and a little triangle with a force, that's fine. Let's see. The upper triangle, the area will be 0.5 times 372 times this height 12. So this force will be 2,232. This rectangle will be 372 times 8 will be 2,976. This little triangle will be 769.6. So the total force F, the total lateral force F will be summation of all these forces. 2,322 plus 2,976 plus 769.9 plus, don't forget the force for water, 1996.8. Sum all of these lateral forces, you can get the total active force. But before calculating the total active force, you have to calculate the pressure. To convert this pressure to force, just piece of cake, you need to figure out the area of these figures. Just a reminder, guys, we have a retaining wall like this. Here is the surface or the ground surface. Make sure if you have water table, I need to, first step, this water will make alone a triangle, lateral pressure. This value gamma water, H water. Which H? Which H at this point? This H only. I'm talking about height of water. If you are talking about soil, okay, I need to figure out the value of pressure here, P1, the value of pressure here, P2, the value of pressure here, P3. P1 equal K active gamma H. We don't have H for soil above 0.1, so your pressure will be 0. P2, actually P2 should be P1, the previous point, plus K active gamma H between 0.2 and 0.1. Probably you have the value for P1, you have to put it here. P3 equal what? P3 pressure at point 3 equal what? Previous point P2 plus K active gamma H. Please be careful. If you are talking about soil inside water, this gamma will be gamma saturated for this soil minus gamma water. Be careful. Be careful. Guys, if you are talking about pressure at point 2, this H between 1 and 2. This H for pressure at point 3, this H between 2 and 3. If you have P4, if you have P5, if you have P6, in the same sequence. Any question? Any question? Okay. Sometimes, so by the end, we found or we converted this pressure to forces. These forces pushing this retaining wall to left. This pushing action probably can cause overturning for the retaining wall about this toe. This point can be called toe of the retaining wall, point of rotation. So we have two moments. One moment, summation MO, which cause overturning, trying to turn or to overturn the retaining wall. We have another moment, resisting. Let me explain it here in more details. If you have a retaining wall, looks like this. And we have soil. And this soil give you this lateral pressure. And this lateral pressure can be converted to a force, F. We need to check against overturning. I have question. This retaining wall will be overturned about which point? I believe this point. Second question, which force will make overturning moment? Which force will try to overturn this retaining wall? Which one? The lateral force? I think the lateral force, F. If you multiply F by this vertical distance, F times this vertical distance will cause moment. This moment can be called MO, overturning moment. Thank you. What are the forces will make resisting moment, will support the retaining wall? I will let you know. This part of the retaining wall has a weight. This part of the retaining wall has a weight. This part of the soil has a weight. This weight supporting this part of the retaining wall. That makes sense? That makes sense? I know we have lateral pressure from the soil, but at the same time, we have own weight for the retaining wall. We have own weight for the soil above any part of the retaining wall. All of these forces will make moment, resisting moment, to overcome the lateral moment or the overturning moment. So if you take moment at this point, this force times this distance, this force times this distance, this force times this distance, I can figure out the resisting moment. If you divide the resisting moment, divide the overturning moment, I can give you the factor of safety. This factor of safety to make this retaining wall safe must be greater than 1. Greater than or equal. It's okay. But for the real life, we need this factor of safety to be more safe. To be more safe, not critical. We need this value of factor of safety to be between 1.5 and 2. Does that make sense? Okay. Let me explain this example. Probably I will postpone the Chekhov sliding next week. Let me do this example. We have a retaining wall with this dimension. The top width is 3 feet. The bottom width is 5 feet. The total height is 10 feet. Made from concrete with gamma equal 155, please. The normal gamma for concrete is 150. Until the problem give you another value, please use the other value given by the problem. Okay. Gamma soil is given 120. We have a water table. We have a water table which is 2 feet from the top of the wall. At 2 feet, this is the water table surface. Let's start to see what's going on. We need to check against or to find the factor of safety against overturning. My first question, this soil behind this retaining wall will try to overturn this retaining wall in this direction. I mean about this toy. Point O. That makes sense. First step, we need to figure out the lateral pressure. We have water, yes. So from this surface of water, we have triangle. This triangle will cause lateral pressure. At the top, at the water surface is 0 pressure. At the bottom surface, we have gamma water, H water. Gamma water 62.4, H water only will be 8 feet. Do you know how? The total height is 10, subtract 2 feet, then this height will be 8 feet. This lateral pressure will be 62.4 times 8, 499.2. For soil, we need to figure out the pressure at this point, P1, pressure at this point, P2, pressure at this point, P3. Remember, we will use a value for K active for a soil equal 1 minus sine phi divide 1 plus sine phi. I think phi is given 36 degree. So 1 minus sine 36 divide 1 plus sine 36. It will be 0.26. So pressure P1 equal K active gamma soil H soil. Do you have any H soil above point P1? No, we don't have any soil above. So P1 equals 0. B2 equal previous value, which is P1 plus K active gamma soil H soil between 1 and 2. P1 0, K active 0.26. Gamma soil is given, what is the value of gamma soil? 120. H of soil between 0.2 and 0.1 is 2 feet. This pressure will be 62.4 pound per square feet. P3 equal P2 plus K active gamma H. P2 62.4 plus K active 0.26 time H of soil between 0.23 and 0.2. Be careful, because this soil inside or under the effect of water, groundwater. So I will use the given gamma 120, but I will subtract 62.4, and the height between 0.3 and 0.2 equal 8 feet. Does that make sense? So this value will be 182.2. So we have a value here 0. We have a value here, how much? 62.4. We have another value here, how much? 182.2, like this. We need to convert these pressure to forces. We have a force here. We have a force here for this triangle. And I will divide this trapezoid to one rectangle and one triangle. Go ahead and find these forces. Let's start with the triangle of the water. 1/2 time 499.2 times 8. This value of force will be 1996.8. This little force will be 0.5 times 62.4 times 2 will be 62.4. This rectangle will be 62.4 times 8, 499.2. This little triangle will be 479.2. So this retaining wall has a force here, another force, another force, another force. The top one, 62.4. This one from the rectangle, 499.2. This one for the little triangle, 479.2. That one from the water, 1,000, too much. 1,996.8. All of these forces trying to make overturning. So what is the value of turning moment or overturning moment? Take moment at point O. This force 62.4 time what distance plus this force 499.2 time what distance plus this force 479.2 time what distance plus this force 1996.8 time what distance to figure out the value of the overturning moment. Please go back to the previous diagram. The location of this force at the centroid of this triangle. So can you tell me what is the vertical distance between this force and point O? Okay, this little distance will be 1/3 2 plus 8. So this distance will be 8.67. The second one, for this rectangle, at distance have 8, which is 4. This triangle, the distance between this force and the bottom will be 1/3 8. The distance between this force and the bottom, this force at the centroid of this triangle, so it will be 1/3 8. That makes sense? So if you get a number, $9,140.3. That makes sense? Looks good. Okay. This retaining wall has weight. This part has a weight W1. This part has another weight W2. Actually, you are lucky because we don't have any soil supporting this retaining wall. What you mean by no soil? I mean, I don't have any soil above part of the retaining wall like this. Okay? So everything is supported only by the weight of the retaining wall itself. What is the W1 equal? Just to remind you, gamma equal weight divide volume. So we have extension in the other direction, which is 1 feet, unit width. So W1 equal, to figure out the weight, you need to multiply volume by gamma. Gamma for concrete 155 is given. What is the volume? What is this length? What is this height? And this width. Go back. This length is 3. This height is 10. So this one is 3. This one is 10. This one is 1 feet. So 3 times 10 times 1. W2, 155 is gamma. What is the volume? For this shape, the area for this triangle is 1/2. This distance will be 2. This height is 10, and the unit width is 1. So W1 is 4,650. W2 1,550 bound. Summation M resistance. What is the distance between W1 and point O? What is the distance between W2 and the point O? I think the distance between W1 and the point O will be 3.5. So 4,650, which is W1, times this distance, 3.5. Plus the second weight, W2, 1,550. What is the distance between this weight and this distance? Is 232. So the value will be 18,341.67. So the factor of safety equal the resisting moment, which is trying to support the retaining wall, 18,341.67, divide the overturning moment, trying to overturn the retaining wall. Your factor of safety will be 2 greater than or equal 1. You are safe. Actually, you are more safe because your factor of safety is greater than 1. The required factor of safety against overturning, we recommend to be from 1.5 to 2. You are good. Over than 2, more safe, but not economic. Smaller than 1.5, you are safe, but still critical. Smaller than 1, unsafe. So guys, if you have a retaining wall and you need to check for overturning, you need to do all of these steps. First, you need to figure out the lateral pressure. Second, the lateral pressure about this point will cause overturning moment. The on weight of the retaining wall, probably weight of some of the soil, will cause resisting moment. When I will use part of the soil to support, if you have part of the retaining wall and you have soil above this part. So this part of the soil will also has a weight supporting this retaining wall from overturning. About this point. That makes sense? If it's okay, you are talking about what in the real life or in our problem? In our problems in the exam or homework, you need only to tell me what is the factor of safety and say it's safe or unsafe. That's fine. But for the real life, Roberto, for the real life, factor of safety for anything in the real life must be greater than 1 because the smaller than 1 is unsafe. So we have factor of safety a little bit above 1, critical, still critical for any accident, for any unexpected events. We can expect failure. Do you remember, guys, the videos you watched last time? I believe factor of safety was very low. I believe the factor of safety was between 1 and 1.5 because for some reason you didn't expect. Probably you have rainfall. Probably you have a truck moving around the site. Probably you have earthquake happened during your construction. All of these unexpected events will cause this small factor of safety very critical. So we can expect failure. So we highly recommend to make factor of safety between 1 and 2 to make sure if you have any unexpected event, you're still safe. A good question. Why I subtracted gamma water? Because you already take water separately. If you didn't subtract gamma water from here, that means you doubled the effect of water, and that doesn't make sense. You already calculated the effect of water alone. So please don't take it one more time with soil. Because gamma of soil underwater is taking the two effect of soil and water, both of them in this gamma. So I need to subtract 62.4. Okay. It's a point related to soil mechanics. So I will not go through this in more details, but at least I need you to know we already take the effect of water, so we don't need to take it one more time. And this gamma, I know gamma here is 120 and the gamma here is 120, but we have a big difference because this one is soil only, but this gamma, which is 120, both of them soil and water, both of them in this value. Okay. Okay, we have another issue. Probably the retaining wall will not be overturned, but it will slide. It will move. No collapse will happen, but suddenly you can find this retaining wall is walking a little bit. Also, this is considered collapse, because if you find the retaining wall walked a little bit, so we can expect failure. We have a house at this location, so the house will move also because everything will be moved. We have here lateral force, which called D, driving force. Driving force, summation of all lateral force. In sliding, we are talking about forces only. Okay, all of the lateral forces will cause summation F of D. What is the value of summation F of R? Can you tell me which force is supporting sliding? Do you know which one? Sliding. Which one will support sliding? Lateral, which lateral? Yeah, I agree with you. We have in this side passive pressure because we have another soil on the other side. So I believe this soil will support a little bit, but we have another source of supporting at this interaction. We have here friction. We have here friction between the concrete and the soil. Guys, if you have a box on the ground surface and you are trying to push it, from engineering mechanics, we learned that we have something here called friction. That makes sense. We have also here friction between the retaining wall and the soil. So summation F of R equal friction force. Do you remember what was the value of friction force? Mu time N. I covered this topic today in the engineering mechanics class. Mu, friction coefficient, equal tan delta. N, summation of all vertical forces on the contact surface. What is the meaning of delta? Angle of friction between soil and the retaining wall. If you get tan, this angle will give you mu, which is the friction coefficient. Let's see. We need the same example. We need to check it against the sliding. Okay, the same steps. We have pressure from the soil, give you a force 1996.8. We have soil pressure, give you a force here, and another force here, and another force here. These values, 62.4. This value, 400. What's the value here? Let me get it from here. 499.2. 499.2. And this force, 479.2. So summation of all forces, of all lateral forces, will be driving force equal forces only 62.4 plus 499.2 plus 479.2 plus 1996.8 equal 3,037.6 pound. Summation of all forces or all resistance forces equal mu time n friction. Mu equal tan delta. N summation of all vertical forces. Yeah, we have a weight here. Do you remember that weight? W1, 4,650. We have another weight here. How much? W2, 1,550. So tan delta is given. Be careful. We have phi. This phi used to figure out the value of K active. 1 minus sine phi divide 1 minus plus sine phi. But delta is the friction under the base of the retaining wall. Tan 26. Summation of all forces, all vertical forces, 4,650 plus 1,550. So tan 26, this value will be 33,223.94. So the factor of safety equal the resisting force 3023.94 divide the driving force 3000. Oh my goodness. Divide this one equal 0.9955, smaller than 1, unsafe. Failure will happen. Something like you watched last meeting will happen. So Chekhov sliding is more easy. You just figure out the lateral forces, sum them together to figure out the summation of driving force. For summation of all resisting force equal any vertical force times tan delta. Then the factor of safety can be figured out. So the key to figure out the to check out the against sliding or against overturning, how to draw the lateral pressure. So be careful about this point.